This is the last video lesson on writing balanced redox reactions. And in this lesson, we are going to look at reactions in alkali medium. So there are some rules to follow for writing a redox reaction in basic medium, a balanced redox reaction. In this, we need to separate the oxidation from the reaction half reaction by using oxidation numbers. So let's go for this process. Cadmium in this reaction's oxidation number is 0 on the reactant side. Then here we have a nickel oxide joined with an hydroxide. Now in hydroxide, the oxidation number of hydrogen is +1 and that of oxygen is -2. Hydroxide has a charge of -1, so that makes sense. Then the NiO must have a charge of +O. In order to form a bond with the hydroxide. So if oxygen is -2, then the nickel must be +3 in order to give the nickel oxide complex a positive charge. Cadmium in this case is +2 oxidation number because it's joined to two hydroxides. The hydroxide is -2 for oxygen and +1 for hydrogen. Nickel in this example it's joined to two hydroxides, so it's a +2 for nickel, -2 for oxygen, +1 for hydrogen. So our cadmium had an increase of oxidation number, so it's losing electrons. So this is going to form my oxidation half reaction. The nickel, on the other hand, the nickel in nickel oxide has an oxidation number of +3 going down to +2, so this would form my reduction half reaction. So we are separating oxidation from reduction. So the oxidation half reaction takes the cadmium and changes it to cadmium hydroxide. The nickel forms the reduction half reaction, so it's Ni O negative and it goes to, O positive, and it goes to Ni 2 plus. I think I made a mistake here by adding this hydroxide here. Just remove that part and change it back to cadmium 2 plus. Right, now we have rules to follow, like with the acidic medium. We need to add hydroxide to balance oxygen, so the reduction half reaction needs an hydroxide ion in order to balance the oxygen. Then we need to add waters to balance hydrogen. So with the reduction half reaction, we need to add H2O to balance hydrogen. But that causes some trouble because I see that by doing this, I should actually just be doing half a hydrogen, but that's not possible. So we need to play around a little bit. We add hydroxides to balance oxygens and waters to balance hydrogens. So in this case, I actually need another hydroxide on the product side. Let's check it. 1 nickel on each side, 2 hydrogens on each side, 2 oxygens on each side. Voila, it's balanced. Next, we need to balance the rest of the elements, and they're all balanced as are. Then we need to add electrons to balance the charge. Now, on this side, the oxidation half reaction, the cadmium has no charge, and on the product side, there is a 2+ charge, so we need to add 2 electrons in order to neutralize that charge. In the reduction half reaction, we've got a +1 charge on the nickel oxide, and we've got a 2+ and a 2 negative charge, making it a 0 charge on the product side, so we need to add an electron. Next step is to balance the electrons. To balance the electrons, we need to multiply the reduction half reaction by 2. 2 nickel oxide will react with 2 waters and take in 2 electrons and form 2 nickel 2+ ions and 4 hydroxide ions. Next, we can write a balanced net equation for this reaction. So, CD, the cadmium will need 2 nickel oxides and 2 waters to form cadmium 2+, 2 nickels, and 4 hydroxides. That brings us to the end of these sessions on writing net redox reactions, whether you can use the table of reduction potentials or not. Thank you for watching the videos. I hope they help you to understand the work.